morning, guys. We've still got some folks coming in. Thanks for joining. Okay, so we have our last session of the conference in this breakout room. My name is Lindsay Marshall. I'm the room captain, so thank you so much for joining us. I'm delighted to introduce you to our next and by no means least final speaker for the day. Saurabh Mishra is the Director of Product Strategy for the IoT division at SAS, and he is going to share with you, as you can see from the screen, information around predictive maintenance with GenAI. So let's keep the energy high for our final session, and let's give Saurabh a warm welcome.
Thank you, Lindsay. Hi, everyone. And I believe the session is being live streamed, so hi to people who are joining online. Last session hour and a big room. I do need to go and talk to the master scheduler before the next one. We're going to be talking about a topic that I believe has the potential to reshape how industrial operations are done going forward, supercharging predictive maintenance with generative AI. My name is Saurabh Mishra. I lead product strategy within our Industrials and IoT division. Let's dive in. I think we've gotten pretty good at spotting when something is about to go wrong. The real challenge is what happens after that. How do I understand what is going wrong and how do I recover from it? That's where the power of generative AI comes in, and that's what we'll be talking about. A technician, when they get an alert, they are left with this navigation of fragmented knowledge to put together a response. It's not the breakdown that's the real bottleneck. It's the brain load that happens after that. Let's unpack this with a situation. Think about a technician on the plant floor. They are running a machine learning-powered predictive maintenance. It's doing its job. It's capturing scenarios when something is about to go wrong and generate an anomaly. So let's say this technician gets an anomaly. These anomalies are surfaced as alerts in their system with some basic information. Reasonably vague, hard to really figure out what happened and what to do. And then it's up to the technician to go and figure out what is the right response, what is the right resolution plan. Think about the delay that this causes while the decision-making is happening and the drag on productivity. Let's ground this with a real example. So let's say you get an alert which says, combustion instability detected in chamber 2. These are fairly common type of alerts that could happen in scenarios where you have power plant turbines, industrial furnaces, any scenario where combustion dynamics needs to be closely monitored. Once you get an alert like this, the real challenge actually starts after that, because you're probably dealing with a bunch of legacy manuals, vendor records, previous maintenance history. And it's up to this technician that received this alert to go and figure that out. And think about, again, the productivity drag that this carries, especially for high-value assets, where uptime is everything. This is where we believe generative AI, and specifically retrieval-augmented generation, or RAG, as it has popularly been known as, can really be a game changer. But before we talk about RAG, let's just continue to unpack this. Why is that previous scenario so challenging? Just look at some of these numbers. These are mind-boggling. A typical gas turbine has over 20,000 components. The OEM manual for this particular GE turbine runs over thousands of pages. The field service bulletin from the OEMs, they could be issuing hundreds of these in a year. It's no surprise that the time to identify the root cause could span hours. And we are talking about high-value assets here. Just look at the number of things that need to be consulted for pulling together an intelligent response. Multiple PDFs, multiple inspection reports going back who knows how many years. And vendor manuals who are probably using their own proprietary non-standard terminology. You could also throw in some emails and handwritten notes in the mix, and this is a real mess. So let's see how generative AI and specifically RAG, retrieval augmented generation, can help in this scenario. So this is what we are thinking of a proposed solution flow, and we're going to unpack this in much detail as we go on with this presentation. So you're talking about a scenario in the top where you already have an operationalized machine learning-based predictive maintenance system that's active. It's running, it's generating alerts. It detects an anomaly, and we talked about surfacing anomalies. But before you surface this anomaly to your technician, you have now integrated RAG in this mix. And RAG has the power to go look at your knowledge base, all those manuals, all those notes, all those vendor logs, maintenance records, to extract just the right context. Now we take this right context and we refine our alerts. So these are no longer just alerts, which are notifications. These are more resolution plans, something more actionable. And that's what we surface, which drives the outcomes. So we've talked a little bit about RAG and how RAG can be integrated into workflow. Probably makes sense to understand RAG a little bit better, because while the concept is simple, that you retrieve some content, generate a response, actual implementation of a RAG pipeline can be complex and multi-step. So let me introduce the RAG pipeline to you. The story, as in most cases, always starts with data. So we're talking about unstructured data here. And as you can see, there's several studies that actually demonstrate that over 80% of enterprise data is unstructured and growing at a really fast pace. These could be in a whole variety of systems, whole variety of formats. As you can see, some of those familiar icons there. Now, our goal is to be able to use RAG and drive outcomes. Outcomes which could include faster access to this information, better technician or customer support, improving operational efficiency, and so on and so forth. But the idea behind RAG is one of decoupling. So we're not taking your data and trying to train a language model around it. We are not even trying to fine-tune a language model, if that's a phrase that you've heard. We're trying to keep your data and your language model separate. But to do that, you need to prepare your data in a specific way so that it can then be connected to the language model just at the time of generating a response. So we need to create essentially a knowledge service which brings your data and the language model, the LLM, together at the right time. This knowledge service can then be manifested as a chatbot or an API that gets integrated in your applications. So I talked about data preparation, and that's where RAG can be complex. So let's unpack this even more. This might not be easy to see, but the idea here is that preparing data before a language model can tap into it is a multi-step complex process. So starting just from the left, you obviously need to be able to ingest the data from the variety of sources, from different file types. We're talking about text data here, so it's all about extracting text. So you need techniques to extract text from those documents, which could get really complex, especially if you have pictures in your documents. Then you might need to use a technique called OCR, optical character recognition. We take tables in the documents for granted, but getting text out of those tables sometimes can be a non-trivial task. So you need to be able to extract text from tables. And this gets me all the text that I have access to throughout my knowledge base. And this text then needs to be organized in logical units called chunks. We are still dealing with these logical units or chunks in text. But before we can actually perform RAG on it, they need to be converted to numbers, and that's where embedding models comes in. It's a pretty popular phrase if you've been following the GenAI space. So we use the embedding models to convert the text into numbers, and these numbers are highly, highly dimensional. To help optimize our search, because ultimately we are going to be searching against these vector embeddings, there are some techniques which include quantization and compression. So you do this, you now have a fine-tuned, optimized set of vector embeddings, and these then get saved in special databases called vector database. So as you can see, fair bit of work here just to prepare data. Once I have data in the vector database, then the runtime magic happens that I talked about. The usual implementations that we are seeing with RAG in the market are a patchwork of manually stitching services that are inconsistent and difficult to scale. And that's where we are innovating. We're taking this complex, multi-step, and sometimes inefficient pipeline and collapsing this into a single application. Our goal is to make RAG more useful, scalable in enterprise setting. And that's the purpose of a new offering that we are working on. The code name for this offering is Project Raghu, and the goal is that it will abstract the complexity associated with RAG that we just saw without losing the flexibility. This is an offering in the works. We are hoping to go generally available in Q3 with an official name. So for the pasta sauce fans in the room, I'm sorry to disappoint you, but we might not be able to continue with the Raghu name. Although we are going to be going generally available in Q3, we have already engaged with a select set of customers and partners and have excellent validation coming back to us. So we are continuing to evolve with this. All right, so now with the understanding of the complex RAG pipeline, how Raghu solves it, and our scenario, which is to help that technician, let's see how it all comes together. So this is the current state, right? So I have an ML-powered predictive maintenance system in place. So on the top left, you have machine data. This could be the turbine that we talked about. This could be the robotic arm. This could be a solar panel. It is whatever your industrial asset is. It's generating data. We can be tapping this data in real time, near real time, depending on the use case scenario. We are running machine learning against it, generating what I think are raw alerts. They have basic information attached to them, and we surface these raw alerts in whatever is the ultimate destination app, which could be the alert diagnostic and maintenance planning app. But as we talked about, these are raw alerts, and they lack context. So now let's talk about adding the RAG layer to it. So the bottom part is activated. So essentially what I've done is I have taken the relevant knowledge-based documents, that could be manuals, parts data, maintenance records, and I have actually prepared them for RAG using Project Raghu. So essentially, I've done all the steps that we saw on the pipeline and stored them in vector database. At this time, they're ready for interaction. So now I get a raw alert. What I do with the raw alert is instead of just surfacing the same raw alert on the display of my app, I actually convert that into a prompt, a targeted prompt. So this is all being done by a system. So the technician is not actually writing the prompt. So we are actually creating the prompt in a systematic manner. We are trying to use the information that we know about the alert from the original system. We send this prompt to the RAG layer, which is the bottom layer. The RAG layer then goes, consults with your documents, prepares the right response for it, and shows it back. Now this is the response that is displayed back to the technician. A much more actionable and a response that provides the right reasoning behind what the alert was. So we can enable this kind of a loop with the RAG layer. But once you have prepared your data for RAG, the bottom layer, you can also enable a more standard maintenance chatbot against it. So even without having a scenario when you have an alert, if somebody wanted to just go and interact with the documents, try and understand what happened last year or last month, or are there any issues that I've encountered in the past with a particular asset, you have access to all of your enterprise data through a simple chat interface. This is the power of RAG. All right, so let's just summarize what we have seen so far. So we've talked about the scenario of turning alerts into clear instructions with the power of language models and RAG, something that allows you to surface the root cause behind these alerts as opposed to just showing symptoms of what happened. We are able to do this by tapping into an enterprise knowledge base. These are your documents. So you can be rest assured that the information that's coming back to you is actually coming from your knowledge base and not something that a language model is just creating out of thin air. And the goal is that we provide a human-friendly, chat-based interface for the technician to have access to this information. This is where the power of generative AI and RAG meets predictive maintenance that we know of. So let's work through this with a real-world scenario that we've been creating within our team. To create this real-world scenario, we use an asset that we call an industrial fan demo. It's actually a small but real representation of what asset monitoring could look like in the field. It has a 3-horsepower motor, a fan assembly. It also has an edge gateway on it, so we can do some local compute right on this device. It also comes with full automation. That includes PLCs, speed controller, and several sensors. And we talked about our starting point being an ML-powered machine learning-powered predictive maintenance. So that's something that we're already doing with this device. So we use an unsupervised anomaly detection algorithm called support vector data description that's actually monitoring as the sensor data is being generated from this device and identifying when I could be creating or I could be entering into an alert situation. And the device allows us to create the alert situation so we can actually test this. But that is the starting point for the RAG part, because once you get to the alert position, then we also have access to several documents that I'll talk about for this device. And we prepared the documents using the RAG layer so that we are able to tap into that, pull together an actionable response. This is where generative AI is ready to meet an industrial equipment. So let's go through how we are doing this. So this is an example dashboard of what was happening before we integrated the RAG layer. So as you can see on this dashboard, we are showing you how we are monitoring the fan. We are showing you the sensor values. And if you can read it, there is an airflow anomaly that was detected, right? This detection happened with the machine learning algorithm that I talked about. So this is value right here, right? I'm not trying to say that you should not do this. This is a good, really solid starting step. You have an anomaly that you have detected. We show you that. We show you the information that we knew about the anomaly in terms of what was happening with the sensor values at that time. But let's take this to the next layer with integration of RAG. And to actually bring RAG into this, we had to create an agentic pipeline. So I'm going to kind of break this agentic pipeline into 5 steps and talk about how we went around implementing this. So the first step is to be able to acquire and load source documents. The story always starts with the documents. We then organize these documents based on what type of these documents are into logical units, and I'll talk about what that means. These logical units, or collections as we call it in Project Raghu, allows for better security, and also these are the units that get processed using the pipeline steps that we talked about earlier. All right, so I now have my documents in, they've been organized, they've been prepared, and then we create the agent workflow, and we'll talk about what the agent workflow looks like. Once the agent workflow is ready, the agent is ready for interaction and a request-response kind of a model. So your calling application, which could be the predictive maintenance application, could then make an API call to the agent and get a response, and this response is then sent back to the calling application, which it can display. A display that is already existing in a way that was friendly and known to the technician. So let's double-click on each of these steps. So I've been talking about documents, manuals. This is what it looks like. So for the industrial fan asset that we have, we went and acquired what kind of documents we can get our hands on. So we found a bunch of documents. And I'll talk about how we organize them on the next step, but these are the documents that we're talking about. These are dense documents. These could be carrying dense technical information, hundreds of pages. But these are your documents. They do exist. They are in your organization that you need to find and load. All right, so now I have all my documents that have been connected and loaded into this pipeline. The next step is to organize these documents. So in our scenario, what we found when we looked at the set of documents that we were able to get our hands on, they were into 3 different categories. So we found manuals, so that became collection number 1. We found maintenance records, That became collection number 2. And we were also able to glean some data from online forums where users were talking about these kind of assets. So that became collection number 3. So the advantage of logically organizing these documents is that now you can have security at that level. So if there's only a certain set of users that need to have access to, let's say, maintenance records, you can actually do that, with the agent being one of them. So you organize your documents in collections, and you also create the processing pipeline. So each of these documents needs to run through the pipeline that we talked about in terms of chunking, the embedding models resulting in vector embeddings, and they get saved in their vector database. So each of these collections are now ready for interaction. So you can go and individually talk to these documents, but in our scenario, in our use case, we need something more complex, and that's why we have the agent layer. This is what the agent layer looks like. So the workflow starts from bottom and goes up. So the starting point for the agent is that somebody has already detected an anomaly, right? So we talked about our machine learning algorithm, the support vector data description was able to detect the anomaly. It then calls the agent, gives the basic information. Okay, this is the anomaly that I've got, and some supporting information. Here is what was happening at the time. So the first step in this agentic flow is for me to just transform and unpack this information, right? So no generative AI involved, just simple code or simple statistical techniques that I might have to do, just unpack and organize the information that I got. So it does that. That's the bottom step. Now it needs to tap into my documents. But before it taps into your documents, you remember the targeted prompt creation, which is really, really important because you can actually get the right information from the language models by prompt engineering your way through it. So we create a targeted prompt using the information that we get from the calling application. And then that targeted prompt really becomes my RAG query to go again the document collection. And you can actually, in the prompt, based on the kind of alert you are dealing with, you can specify what collections you want to go through. In this case, we went through all 3 collections. But there could be some more specific scenarios where you just need to go to one collection. That's all possible because the agent development is flexible to your use case. So we go against my document collections, and I pull together, I retrieve a response. And the last step for us is to really curate and format that response in a very special way so that it's meaningful for a technician. So we do that in that topmost box. One of the things that we added on the right side, which you see with the dashed line, is it's a test scenario for us. When I get a response back, you can further critique that response and improve that response. So you may actually employ a language model just to critique and improve the response in case you wanted to just have that one additional check. That's something that's possible in the agent pipeline. We have tested it, but for our main scenario, we did not include that. So anyway, so now this is my agentic logic, where I have taken the input information that I got, I unpacked it, I then created a prompt with it, I took that prompt to my collections, the collections returned me some information, I organized them, formatted them, and I returned it back. So now this agent is essentially a block for me, right? So this block can be then invoked and integrated into whatever workflow I have. And this is what the next step looks like. So on the left is my predictive maintenance flow, right? So remember the support vector data description, that machine learning algorithm, that is being implemented in this workflow depicted on the left, right? So that's the process that was already happening. And once I get an anomaly, that exec query step is where it invokes the agent flow. So this agent flow, because it's an API integration, it's a code-based integration, which is shown on the screenshot on the right. What is really powerful about this is that your agent is completely separate and isolated from your calling application, right? So your predictive maintenance application on the left can continue to evolve and get enhanced. And your agent could continue to get involved on its own. You are not tight coupling them. And that's why we have an API integration to bring it all together at runtime. So that's how your predictive maintenance application connects to the agent and gets a response back. And now this is the final step. Once I've received my response, I then add this response back to my dashboard. And look at the details that we were able to glean from the documentation. For the airflow anomaly, we now understand the probable causes. So we show that. We talk about the recommended actions. So we show that. But to make sure that a business user, a technician, an operator can trust it, we also show the sources, where we got this information from, which documents were consulted, in fact, which portions of these documents actually we used to compose this response. So we really want to make sure that there is no mystery around it. These responses are fragmented, but they are in your documents. And this agent was able to crawl and pull it all together. So that's the power of an agentic layer with trustworthy AI built into it. So our goal is to be able to do more of this, and we see a lot of real-world impact that's going to be created with this. So we talked about issue resolution that becomes critical in high-value assets. So we're starting to see some results where the resolution time could drastically go down. So you talked about the turbine example where just to find the root cause, it was taking upwards of 6 hours. That can be collapsed significantly. We're talking about enabling clear, context-rich interaction. All of this, the goal is to reduce downtime that we talked about, and less alert fatigue. And in some cases, it's not just the alert fatigue that we're concerned about. In some of these M&D centers, when technicians are getting alerts that are coming fast and furious at them, they may actually think about more general, suboptimal ways for handling with these scenarios. So we can eliminate that. The ultimate goal is to empower maintenance teams with knowledge democratization. And this is really, really important as we think about the changing workforce in manufacturing. Everything that we've talked about shows up on this maturity curve, right? And it illustrates where we started and where we are going. So our starting point in this scenario was the machine learning-based predictive maintenance. We use that to detect anomalies faster, and we talked about that's value right there. But then we talked about the fact that just getting an alert back from that ML-based predictive maintenance was not sufficient, so we integrated RAG into it, and that helps us get better responses, drives contextual response. But the final unlock is happening with the agentic layer. That's where we are able to create more of a tailored workflow for your use case, which brings not just the RAG together, but other techniques, custom logic, code, database call, whatever you need to do to then generate an enterprise-ready response, and in some cases, actually perform action for you. So back on that industrial fan demo, we talked about automation that was bundled in. So if I found a scenario that needed a fan speed to be reduced, I could integrate that with the PLC that is on that device to perform that, if that's a lowest stake task. But in some cases, if you need human in the loop, that could generate a notification for the human to perform the same thing. That's all the content that I had. We talked about the concept of balancing generative AI and traditional ML for enhanced maintenance. I think we have a few minutes for questions if you guys have, or just feedback or thoughts. Thank you.
Thank you, Saurabh. Curious how much either implementation cost or cost of the technology, from talking to a client about, I would like to do something just like that.
Yeah, so this is, as you can imagine, this is pretty early in the process. We are at the front end of it. So we are looking at various aspects that could drive the cost. So there are a few dimensions that I can give you, which impact cost and how we are thinking about it. One aspect of it is also to do with cost control, but also just regulatory concerns. So we can run this entire thing on-prem, if that's important to you, especially important in regulated industries. So that's one. That also has an impact on making multiple language model calls can add up. So you could actually have a local LLM in the scenario of an on-prem deployment that could also reduce the cost. So that's one aspect of it. The other aspect of it is that as we talk about bringing all of these documents that you have, I mean, this could be a massive knowledge base. And that's why we've added optimization techniques. When you convert the documents into vector embeddings, these vectors they could have thousands of dimensions. And for us to be able to optimize and compress it is really helping kind of manage the vector database sizes to help with the cost part of it. Everything that we have done here is built on top of a product called SAS Event Stream Processing, which is a mature, ready product, really optimized and compact architecture. So our footprint in terms of just compute resources is really, really small. But as I talked about, this is early in the process. So we are just starting to engage with customers who are trying to figure out how much scope they want to bring in. So we probably need some more time before we have some more real hard metrics around the cost aspect.
Awesome. Thank you. What are you using in terms of a vector database? Or is that pretty open?
Yeah, that's a great question. So our story with Project Raghu is that we are agnostic of the core generative AI services, whether that's the language model or the vector database. So under the hood, we use the LangChain framework that has hooks to whole variety of vector database. So we can connect to possibly any vector database that you can think of. But for the work we have been doing so far, we have native integration with VV8 and pgvector, which is the vector counterpart of Postgres. So those are the native integrations that we have, but we can really connect to any vector database that's out there. Good question.
Great presentation. This was for events in action. What about using this for root cause analysis based on sequence events logs or alerts that have already been registered? Do you see an obstacle to that?
No, I think that's another example where an agentic workflow could come in. Now, in that scenario, you may have a combination of generative AI and more traditional techniques that need to be combined. So having a RAG layer might not be enough to just provide that response, but that's exactly why agents are so powerful, because they can mix and match. So adding the right RAG layer with statistical or more deterministic models could help us power through those scenarios as well. Yeah. I can hear you, guys. Go ahead.
Thanks, Rob. Thanks. Great job. Hey, back on the quantum. It's being recorded.
Oh, that's true. We are recording.
Thank you so much, Saurabh. Hey, so back on the data collection side and the quantification or quantitizing of the and I know this is a loaded question because I know the answer, it depends, but have you built a pipeline mechanism to help accelerate the refresh of the vector database? Because in the real world, as you know, if one of those data sources is logs,
Yes.
it's constantly changing. So what type of pipeline are you guys looking at to keep that vector database fresh?
Yes, that's an excellent point, because that's a reality in enterprise settings, that while some of my documents could be static in nature, some other could be dynamic, could even be streaming in nature, right? So because under the hood, as I talked about, the product that we use for this is Event Stream Processing, which has built-in support for streaming. We can scale as the documents are changing in terms of their content getting refreshed. So we can support any kind of dynamic changes on the documents, from static to something that's changing multiple times a day. But we also support generating a pipeline. So because once your document changes, you need to be able to kind of refresh the entire RAG pipeline as well. So we support an automation aspect where you can connect the documents that are changing to the RAG layer, so that as soon as new content comes in, we actually run it through the pipeline, vectorize it, save that into the vector database, and then could trigger the agent that was connected to it. And you could choose your indexing update strategy, because again, when you're updating these vector databases, you have some options. Do you want to just do a complete refresh? Do you just want to do an incremental thing? So all of that is fully supported in our pipeline.
Perfect. Thanks.
Yep.
Okay, good. Well, thanks for the presentation. So let's say a plane has 50 machines. Each machine has a ton of motors, sensors. How do you structure that data? And also, the second one is, you say that the system can go out on the internet and get information out there. how do you have to supply links, or the system just kind of does it like Google, go out and search for stuff?
Right. So there's a lot of flexibility there, right? So that's actually really a decision that you as an organization has to make. So your first question about how do you kind of organize your data, right? So that just really depends on a couple of things. The type of data, what attributes are we talking about, whether these are manuals, maintenance records, or they're by region, and you want to kind of keep it separate by region. So the type of the documents, and then the associated security you want to drive with it, right? So if there is some level of consideration that these documents should only be accessible to a particular department, it makes sense to create a single collection around it so that you can manage security accordingly, right? So it really depends on your context and your scenario in terms of how you want to organize these documents. So that's part one. The second part was about internet data, right? So in some cases, a lot of this data is already static, already available. We can connect to that. But if your scenario requires a continuous refresh from internet data, this is not an industrial example, but we are also demoing another use case where we were actually pulling some financial data in real time. We can also do that. We also have connectivity options for you to go and pull data from the internet and bring it all together in a single pipeline. And that's something that can be either scheduled or you can do on demand. But the answer is that yes, we can combine both static data that your organization already has with new data as it is generated on the internet.
Thank you.
Sure. Any other questions?
Just on the underlying concept that you said, right, the SaaS event stream processing.
Yes.
Is that something that can be broadly applicable across other use cases? Like, for example, I'm not in a manufacturing background, but we are in a pharma setup. So to do predictive maintenance on our VIA cluster, for example, where when we have critical time periods for study submissions and things like that, is that something that could be used to do the maintenance on VIA itself?
That's an interesting question. SaaS event stream processing is a generally available horizontal product, right? So we use it in cross-vertical multitude of use cases. So that's first part of the response. And for monitoring a VIA cluster, I mean, as long as you're talking about that you're generating, let's say, machine data, log data, I don't know, user interaction data that needs to be processed in somewhat of a near real-time fashion, then I don't see why not. We just have to look at, like, maybe there are tools that the platform itself has that is allowing you to kind of get access to that data without you doing all of the heavy lifting. But in general, yes, we have dealt with use cases. For example, a use case that we've dealt with was data center monitoring, right? Where you have machines, so you have machine data, and you also have environmental data, like humidity, temperature, things like that, and processing all of that to make sure that you have the optimal environment for data center management. So we've done that. So it sounds similar to that, but I would first look at maybe platform already has some capabilities. But in terms of ESP being used for use cases like this, yes, that's totally possible.
Okay, because I'm only familiar with the enterprise session monitor from SaaS at this point, for monitoring our environment. And that's not really predictive, it's more reactive and,
right.
formative. So, which is why I was asked, but thank you.
Yep, sure.
Anyone else? No? No more for any more? Okay, thank you so much. I'd love if we could give a massive thanks of appreciation for Saurabh for his session today. I think it was super informative. Thank you so much.
Thank you.
That was really good.
Thank you.